Tonight our focus was on solving systems by elimination. Problem number 1, write the equation in standard form. We should remember that standard form is ax plus by equals c. So our goal is to get x and y on the same side of the equation. Right now x and y are on different sides of the equations, so I want to move the x over to the same side as the y. I'm going to accomplish that by subtracting 3x from this side, which will leave the negative 5 all by itself. What we do to one side of the equation, we have to do to the other side, so minus 3x over here also. That's going to end up with negative 3x plus y equals negative 5. Well, we can see we have ax plus a b value of 1, y equals our c value of negative 5. Problem number 4. Solve each system of equations using the elimination method. Now, the elimination method is what we talked about in class today, and that's basically eliminating one of our variables by adding the two equations to each other. In order for a variable to eliminate, we're going to have one variable with a negative value and one variable with a positive value, and their coefficients, the number in front of the variable, must be the same. Since my y has a coefficient of 1 in front of both y's in each equation, I'm good to go. I can also notice that one equation has a negative y, the other equation has a positive y, which means when I add the two together, they're going to equal 0 and cancel out. So this works something like this. X plus 2x equals 3x. Negative y plus y equals 0 equals 11 plus 19 is 30. Now 3x plus 0 is the same as saying 3x, so 3x equals 30. We'll divide by 3, and x will equal 10. Now that we know the value of x, we can plug the value of x into our equation. X, which is 10, minus y is equal to 11. So I will subtract 10 from both sides. Negative y is equal to 1. That would be great if I want to know what negative y is, but I don't want to know the value of negative y. I want to know the value of positive y. So we're going to divide by negative 1 to get y isolated all by itself. So y will equal negative 1. Since we have an xy value, we know we have an ordered pair that is 10, negative 1. Now, it's always beneficial to check your solutions. So we have an x value of 10 minus a y value of negative 1 equals 11. Minus a negative is going to become positive, so 10 plus 1 is 11, which equals 11. It does, in fact, so we check it. We got that right. I'm going to check my ordered pair into the other equation just to make sure that we didn't make any mistakes. 2 times my x value of 10 plus negative 1, my y value, equals 19. 2 times 10 is 20 plus negative 1 equals 19. 20 minus 1 is 19 equals 19. That is in fact true. Number 6, 2x plus y equals 11. X plus y equals 9. Well, I can again see that the y value has a coefficient of 1 for both of those equations. But this time, both of them are positive. And since when I add y plus y, I get 2y, that's not going to clear anything out. We have to manipulate one of these two equations to create a negative y. And the way we do that is the same process by which we cleared fractions earlier this year and the same process by which we cleared decimals earlier this year. We simply multiply the entire equation by -1. Now that's going to give us the exact same equation, and we discussed in class how we could use our order of operations to subtract x and subtract y and subtract 9, and they would all move across the equal sign and give us the same final result. But it's simpler to just go ahead and say -1 times x is -x. -1 times y is -y. -1 times 9 is -9. And now I'm not going to use this equation anymore until we get to the very end and we're ready to check our solution. So I have my first equation and my second equation. 2x plus -x is simply x. Y plus -y is 0. 11 plus -9 is 2. So x plus 0 is the same as saying x equals 2. Well, now is where we can plug our x value back into one of these equations, and I'm going to use the one that we crossed out because it's simpler. X, which is 2, plus y equals 9. So I subtract 2 from both sides. Y equals 7. So our ordered pair is going to be 2, 7. That's where these two equations will intersect, and we want to check our solutions. So we have 2 times our x value of 2 plus our y value equals 11. 2 times 2 is 4 plus 7 equals 11. 4 plus 7 is in fact 11, which equals 11, so we checked our solution. We want to do the same for our second equation. 2 plus our y value of 7 equals 9. 2 plus 9 is in fact 9, which does equal 9, so we've checked our solution. Problem number 8. Problem number 8. Well, we have a 2x and a 5x. Neither one of those match. And we have a 3y and a -y. I see a little bit of help there because at least one's positive and the other is negative, but neither one have the same coefficient. So just like on the previous problem, we could multiply one of the equations by -1. We can also multiply an equation by an integer. So I'm going to multiply this entire equation by 3. Multiplying it by 3 will leave me with a -3y, which is the opposite of 3y, and so I can tell that those two are going to eliminate, giving us the ability to solve for x. So 3 times 5x is 15x, minus 3 times y is 3y, equals 3 times 3 is 9. And again, I'm going to cross that out lightly so we can come back to it later, but I don't want to feel like it's there and accidentally use it. So we have 2x plus 15x is 17x. We have 3y plus -3y, which is 0. And we have 8 plus 9, which is 17. 17x plus 0 is 17x equals 17. We divide by 17 on both sides, and x is then equal to 1. Now that we know the value of x, we're simply going to plug it into one of our two equations. I'm going to use the bottom one here that we crossed out because that's simpler. 5 times 1 minus y equals 3. 5 times 1 is 5, minus y equals 3. So I'm going to subtract 5 from both sides and be left with negative y is equal to negative 2. And if I divide both sides by negative 1, we're left with y equaling 2. So again, I have an ordered pair that is 1, 2, and we can check our solutions. Two times 1 plus 3 times 2 should equal 8. 2 times 1 is 2. 3 times 2 is 6. That should still equal 8. 2 plus 6 is 8, which does in fact equal 8, so we're good on that equation. We want to check our solution to our ordered pair in the other equation. Remember, we always go back to the original. We never work with a manipulated one, because if for some reason you make a mistake in distributing through your original equation, your ordered pair may work for your manipulated equation and one of your originals, but not actually work for that. So we always check back to the original equations. 5 times 1 minus a y value of 2 equals 3. 5 times 1 is 5, minus 2 should equal 3, and 5 minus 2 is in fact 3, which equals 3, so we're good to go. Now, we haven't done a whole lot of word problems right now, so I wanted to at least look at this one. Write a system of equations for the situation. Solve the system using the elimination method. So, we're going to start with 35x plus 50, because it cost me $35 per month, plus the original $50 enrollment fee, is going to equal my total cost. Well, I can already see that this is not in standard form, so before I do anything, I'm going to change it to standard form. Subtract 35x from both sides, and we're left with negative 35x plus y equals 50. All right, now let's look at the other. The fitness studio offers $40 per month plus a $35 enrollment fee, and that's also going to equal y. So again, we want to write this in standard form. Minus 40x, which leaves us with negative 40x plus y equals 35. Now, I can see right away that if I stack these two on top of each other, one is going to have a positive y, the other is going to have a positive y. So if I add those variables together, I'm going to end up with 2y. I have a negative 35x and a negative 40x. If I add those two together, I'm going to end up with negative 75x. I don't want either one of those. I need a y value, or a value here, which is y with a coefficient of 1, and I need its opposite, which would be a y with a coefficient of negative 1. And so we're going to accomplish that by multiplying one of these equations by negative 1. And you're going to notice I'm going to take my work and go ahead and transfer it over here while I do it. Negative 1 times negative 40x is 40x. Negative 1 times y is negative y. Negative 1 times 35 is negative 35. And so now we're simply processing through elimination, because that's what our question told us we must do. Since both of these started off with something equaling y, I would have preferred to do the substitution method. But since we were told to use this particular one, we're writing them both in standard form and setting them up to eliminate a variable. So negative 35 plus 40, well, that gives me 5x. Y plus negative y gives me 0. 50 plus negative 35 gives me 15. So 5x equals 15. We divide by 5, and x is equal to 3. Well, now that we know one of our variables, we can solve for our other. We're going to start with an original one of either of our equations, just in case we made a mistake. So, let's see. Let's go ahead and take the 40 because it's going to be easier to multiply by 3. 40 times 3 plus 35 has got to equal y. Well, 40 times 3 would be 120 plus 35 equals y. 120 plus 35 is 155 equals y. Well, we now know our y value. We previously solved for our x value. In how many months will the fitness clubs cost the same? Well, in 3 months, which is what our x value represents, months. And remember, we got that from our original problem where it said $35 per month, and that's why we substituted in a variable. So in 3 months, both clubs will cost $155. Now, I certainly encourage you to check your solutions, which means you will check this ordered pair 3, 155 in both of your original equations just to make sure that it works. I'm not going to do that in the video because we are already at 17 minutes, so hopefully this has helped you to be successful in solving equations with the elimination method.